When we create new functions from old ones, often something we want to figure out first is the domain of that new function. And in this example, we're going to look at the domain of a composition of f and g, where f and g are given with by using formulas. And I'm going to give you two solutions, okay, to find the domain of a composition. Maybe the one I would actually do myself and the one that the book does, and then you can decide what you actually prefer. So solution number one, we are going to compute, okay, f of g of x directly, and with the expression we get, with the formula we get, we're going to find its domain. So we are going to compute f of g of x and find its domain. Okay, and that's and we'll find its domain directly. Okay, now we have f of g of x. This is f of, so what's g of x? It's 4, 3x minus 2. So that becomes the input to function f. So remember, function f, it takes an input. Okay, you can replace the input by a box. And the output is 5 over whatever was in the box, to which you subtract 1. Oops, and I wanted to do that in black. Okay, so we're going to put 4 over 3x minus 2 for the input. So yeah, the output is going to be 5 over 4 divided by 3x minus 2, to which you subtract 1. So that's the output here. So 5 over 4 over 3x minus 2, and you subtract 1. And that's the expression you get for the composite of f and g. We could simplify this, okay, especially like if I wanted to work with this expression more efficiently, I would simplify it. But to find the domain, I don't have to do this, okay? So here we're going to be efficiently lazy. I just want the domain. So so for us right now, remember, when you want to find a domain, there are basically two cases you want to watch out for. You don't want to divide by 0, and you don't want to take the square root of a negative. Here there aren't any square roots, there are only divisions, so all we're going to worry about is not dividing by 0. Okay? So here's what we cannot have. We cannot have, there are two division symbol here, okay? So if I look at this one here, I don't want what's underneath it to be 0. So I cannot have that 3x minus 2 equals is equal to 0. And there's something else, and we cannot have, there's a second division symbol, we cannot have, what's the other one, division symbol? It's right there. So what's underneath it, which is all of this, okay, it cannot be equal to 0. So that means that 4 over 3x minus 2 minus 1 cannot, we cannot have this equal to 0. So basically, all I need to do is solve these two equations, okay? And the values of x that I get, I'm going to remove that from all real numbers, and that's going to be my domain. So now, if I solve 3x minus 2 equals 0, that's 3x equals 2, or x is 2/3. So immediately I know 2/3 is not going to be part of my domain. And then I need to solve the other one here. Like that. I could solve it in many different ways. I could put everything over a common denominator, but here I'm just tempted to send the 1 on the other side. And then multiply by 3x minus 2 on both sides. And then add 2 on both sides and divide by 3. So we're going to exclude x, we're going to exclude 2 as well. So I'm going to write the domain of f dot g. Remember, we put f dot g as a subscript to the word, well, the abbreviation dom, or you can just put domain. Like this, maybe me being lazy, but anyway, I can put all domain of f dot g is equal. So it's the set, all real numbers, but remove the values 2/3 and 2. Okay, and that's the answer. And that's the solution I actually prefer. So we're going to take a look at the solution we find in the textbook. And then you can decide if you prefer that. So solution 2, okay. Solution 2, they focus on how you actually calculate f of g of x, okay. So to compute f of g of x, first thing you need to calculate is g of x. So if you can't calculate g of x, right, if that x is not part of the domain of g, then it's not going to be part of the domain of the composition, because you need to calculate g of x first. Okay. So first, g of x must be defined. It must be something that exists. Okay, so this means we're going to exclude values of x not in the domain of v, not in the domain of g. Okay. So one thing we need to know is what's the domain of g. So try to answer that question. Now the domain of g is all real numbers except those that would make the denominator 3x minus 2 0, and we know that that occurs when x is 2/3. Okay. So those values not in the domain of g are, well, there's only one here, 2/3. We're gonna have to remember to exclude that 2/3 from the domain of the composition. Okay. And now, since g of x is going to become the input to f, g of x needs to be in the domain of f. So that's the next condition. Now, g of x must be in the domain of f. So we need to know what that domain is. The domain of f is what? Well, it's going to be all real numbers except what makes the denominator 0, except 1. So which means that g of x, if it's in the domain, it cannot be equal to 1. If it's equal to 1, it wouldn't be in the domain of f. So that means that I'm going to have to exclude other values. Exclude values of x where g of x is not in the domain. Okay. So we cannot have, I cannot have g of x equals 1. That's not possible, because otherwise g would not be in the domain of g of x would not be in the domain of f. So g of x is what? The expression is 4 over 3x minus 2, and that when solving this, that's going to give us also a value we need to exclude, but we've done this already, right? So this part that I've done here, that's exactly it. So that's going to give us, once again, x equals 2, which means that if we summarize what we found, we need to exclude values that are not in the domain of g, so we need to exclude 2/3, and we need to exclude values that of g of x such that g of x equals 1, because f is not defined there. So overall, the domain of f dot g is going to be all real numbers, and then I exclude the values I just found. So I found what I found. I need to exclude 2/3 and 2. So of course I get the exact same answer as before. Personally, I really prefer the first solution. I find it's clearer. There's actually less writing to do. And we're going to do another one. So find the domain of f dot g where f of x is root of x plus 2 and g of x is 1 over x. Okay, so once again, two possible solutions. Solution 1 is my method. So what I do here is I calculate directly f of g of x, and then with the expression I obtain, I try to figure out what I cannot have in the expression obtained. So try to do that. So get f of g of x, and then try to see what restrictions there are you have in the formula, and then that should give you what the domain is. So f of g of x is f of 1 over x. Now 1 over x becomes the input of function f. So which means, you know, f of the input is whatever is the input to which we add 2 and we square root. So the output is here is going to be square root of 1 over x plus 2. And that's it. Okay, so that's the formula for f of g of x. Okay, so now remember, I cannot take the square root of a negative. I cannot divide by 0. So there's a division symbol and there's a square root. So that means I probably have to deal with two restrictions. So we cannot have, first of all, a division by 0. So here, x, which is the denominator of the ratio, cannot be 0. So we cannot have x equals 0. So that's already, I mean, there's nothing to solve here. Like we already know x cannot be 0. And I cannot have 1 over x plus 2 being negative. That's not possible. I cannot take the square root of a negative. So here I'm going to try to solve this for x. I could again put it over a common denominator and try to solve it, or maybe send the 2 on the other side. That's another possibility. I will multiply by x on both sides and divide by minus 2, and that's going to change the sign of the inequality. Now this problem is actually trickier than I thought it was, because there's one thing, maybe you didn't catch it while I was doing the solution, or maybe you did and then you trusted me, but maybe you shouldn't have. At this step, you see where I sent the x right there, right between here and here, I've sent the x on the other side, multiplying by x, and look at my inequality, it didn't change direction. So that's going to happen if I'm multiplying by a positive x. Otherwise, if x is negative, it's actually going to change the direction of the inequality. So what I wrote there is only true if x is positive. Okay, so this is going to be, I need to keep that in mind, if x is positive. And look what I get at the end. I get that the solution, if x is positive, is that x is less than minus a half. Now wait a second, if x is positive, it cannot be less than minus a half. So this is not possible here. Okay, not possible. I don't have any x's that satisfy this. So here there's actually two cases to look at. There's this case, but there's also another case where maybe x is actually something that's negative. So in that case, if I multiply by x on both sides, it's actually going to change the direction of the inequality. So yeah, it's a bit tricky, eh? So this is a restriction I need to remember. Now if I solve for x, x is going to, and now I'm going to divide by minus 2. That's again going to change the direction of the inequality. So I get minus a half here. So the solution is x is greater than minus a half, but it has to be something that's less than 0. okay? And those are the values I need to exclude, okay? So so the domain of f dot g is going to be okay, hang on, I'm getting confused a bit. So I need what? I need to exclude the here's what I need to exclude: minus a half, 0. This I exclude. So essentially, instead of excluding it, I'll just show what I keep. I'm gonna keep this and this, but I also need to exclude 0. Okay, so so that means that my domain will be this. I need to exclude 0. So the domain will be, I can write it in interval form. That's easier. So from minus infinity to minus a half included, union 0 to infinity. Maybe very quickly, another way to look at this problem is just to look at the graph of 1 over x plus 2. Now 1 over x is from our toolkit functions. It's a graph that looks like that, with the x-axis being an asymptote and the y-axis also an asymptote. And if you look at 1 over x plus 2, basically you add to all y values on the curve, you add 2 to them. Okay, so so if you've got a point here, you have to move it up by 2. Okay, so you move everything by 2. So in particular, this asymptote we have here, which is the x-axis, gets moved up by 2. So it becomes the line, the asymptote becomes the line y equals 2. And our curve looks like this now. Okay. And when we want to take the square root of that y, which is 1 over x plus 2, we want to make sure that y is positive. Now we can see on the graph where y is positive, it's where the graph lies completely above the x-axis. So for those x values, the graph or the values of y on the curve are above the x-axis, and the x-intercept here, which is minus a half 0, which is easy to obtain. You just equate 1x plus 2 to 0. See, so this is actually pretty easy to do, right? And then you get x is minus a half, like that. So that's how you get the x-intercept. And then it's pretty clear. You see in green is the domain of f dot g. So it's going to be from minus infinity to minus a half, and from 0 excluded to infinity.